16 40 by 9 meters will be the distance of the platform from the initial position when it falls on it. Maximum height attained by the ball from the ground. The maximum height from here I should be able to calculate this. I projected this with a velocity of 8 meters per second. When will the velocity become 0? That will be the maximum height. V is equal to u minus gt. But remember, this 8 is the velocity with respect to the platform. With respect to the ground will be 8 minus 2 minus 10 into t. Put this as velocity. You will get the time it takes to go to the maximum height. Or rather, instead of using this, use v square is equal to u square minus 2gh. But initial velocity of the body with respect to the ground you will take as velocity of the body with respect to the platform plus velocity of the platform with respect to the ground. That means it is 8 plus 2. This is 10 meters per second square. Velocity of the body with respect to the platform plus velocity of the platform with respect to the ground. It will be 8 plus 2. That will be 10 square.
Yes,
right?
sir.
You will get the maximum height to which it goes because at the highest point the velocity is 0. You are solving that problem with respect to ground because he wants it with respect to ground. Third, maximum distance of the ball from the platform. Obviously, maximum distance should be the maximum. No. Maximum distance of the, quite obviously, have a look at it. S is equal to ut plus half at square. The distance should be maximum between them. That means, first of all, I take relative, and relative. Watch out for this. Relative displacement SR, this should be maximum is what he is asking. When will the distance be between the platform? Now, what will be the initial relative velocity? 8t plus half. This will be minus 10 minus 2t square. dsr by dt should be equal to 0. You will get the time after which the displacement will be maximum. This is relative displacement. Relative displacement means displacement of the body with respect to the platform.
Yes, sir.
Displacement of the body with respect to the platform. Right? So if this is maximum, how do you get the condition for maximum? Differentiate this with respect to time and equate it to 0. You will get that time. So resubstitute that time here. You will get the maximum displacement. Can I have the board?
Sir.
Now in the last problem, an elevator starts from rest and moves upwards. An elevator starts from rest and moves upwards, accelerating at the rate of 1.2 meters per second square until it reaches a maximum height of 7.8 meters per second, which it then maintains. Maximum speed, V maximum attained is 7.8. Keep that in mind. You will never require that because I remember having done this. This bolt will reach the A floor even before it reaches the maximum height, which it then maintains. 2 seconds after the elevator begins to move. 2 seconds after the elevator begins to move. That means you are here somewhere. 2 seconds. After 2 seconds, bring this body down. After t equal to 2 seconds. Right. We would like to know, where am I? After 2 seconds after the elevator begins to move, a man standing 12 meters above the initial position of the top of the elevator throws a ball upwards with an initial speed of 20 meters per second. He is standing at 12 meters from the initial position. This man throws the body upwards. It will go up and come down.
So the distance 12 meter is from the top part of the elevator, not from the base of elevator.
Initial position from the top of the elevator, 12 meters. Where am I? Yeah. Above the initial position of the top of the elevator, throws a ball upwards with an initial velocity of 20 meters per second. He sends it with 20 meters per second. Determine when the ball will hit the elevator. Firstly, this was what I was trying even for the first problem. First what we shall do is, first to verify if, firstly after 2 seconds, what is the velocity of this?
2.4.
2.4 meters per second. Right. Secondly, in 7.8 meters per second velocity, if it should acquire, what was that he says? Until it reaches, it accelerates this way until it reaches a maximum 7.8 meters per second. That means for how much time is it accelerating?
6.5. 6.5 seconds.
6.5 seconds is the total time of acceleration of the elevator. So, first part of the problem, I'll have to verify if this ball falls on the elevator before 6.5 seconds. Then the problem is solved there itself. I don't need to go for the rest. For which I use this parameter, the relative displacement SR is equal to UR into T plus half ER into T square.
Yes, sir.
Now I know this distance covered in 2 seconds. What was this distance covered?
2.4.
How much? 2.4 is the velocity
2.4.
acquired. This distance.
It is also 2.4.
That is also
2.4.
Right? How? S is
Sir,
equal to
half AT square.
Half it is square.
0.6
this is
into
2.4
4.
meters. That means the relative displacement here will be this distance. This is 12 minus
9.6. So answer is 9.6.
how much is this distance?
9.8.6. 7.6.
12 minus
That's-
2.4 here.
9.6.
9.6 meters. Why are you telling me 7.4, so on and so forth? Listen. So this will be the relative displacement. Fine.
Yes. Yes,
The
sir.
body is thrown here when this is here. So somebody in on the top of the left will see that the body came down by a distance of 9.6 meters. Firstly, that is in the downward direction, minus 9.6. Initial velocity of the body is 20 minus the velocity of this is 2.4 t plus half acceleration of the body minus the acceleration of the elevator. Acceleration of the body is minus 10 minus acceleration of the elevator is in the upward direction. This is 1.2 t square.
Excuse me, sir.
Yeah.
Sir, it will be minus 20 minus 2.4. Sir, because velocity is downward of the ball.
Body is thrown upwards with a velocity of 20 meters per second, and this is the initial
Yes.
relative velocity. Upwards will be 20 minus velocity of the
2.
this is 2.4 in the upward direction. So these both values
Yes,
are
sir.
positive. Now acceleration I put minus 10 for this because it is in the downward direction, minus acceleration of this is in upward direction. And why did you put minus 9.6? Because the displacement is in
Downward direction.
Now this time, simple parameter, the time which you get from this equation, if it is lesser than 6.5, that's your answer. Your problem is solved.
Yes, sir.
By chance, if that time doesn't turn out to be less than 6.5 seconds, then you will have to restructure the problem. You'll have to cut this.
Excuse me, sir.
Yeah.
So the ball is thrown after 2 seconds when the lift begins to accelerate. So we have to take 4.5 seconds because the lift has already covered some distance before the ball was thrown.
Yes, sir.
So it will not be 6.5, it will be 4.5.
Yes, sir.
Priya, you mean to say,
When the lift
So there is a difference of 2 seconds.
yeah, in the 2 seconds I have taken 2.4.
But the time should be 4.5 seconds.
Sir, it should not
Why?
be 6.5.
Because already after 2 seconds the ball was thrown and the lift accelerates for 6.5 seconds. 2 seconds of 6.5 is already covered.
No, just a minute. After 2 seconds the ball is thrown means the elevator was here when the ball was thrown in the upward direction.
That means from 6.5 seconds which it takes for acceleration, 2 seconds is already over.
You mean to say from here the time will not be given as 6.5, it will be lesser than that. Yeah, quite obviously. Because right from the start he is telling you, that means this took 2 seconds. Now
Yes,
the
sir.
remaining time it takes to come should be lesser than 4.5 seconds. The time which you
Yes,
calculate
sir.
from here is lesser than 4.5 seconds. Then that will be your answer. Yeah, quite reasonable because already 2 seconds is over. Now actually
Yes,
your
sir.
answer finishes off here. Your answer finishes off here for these values. Suppose in any problem he gives you values in such a way, such that you realize that this time you are not getting a proper value less than this, less than 4.5 seconds. Then you will have to restructure whole of the problem. Firstly calculate that in 6.5 seconds total this elevator will cover how much of a distance? What is the velocity acquired? Then the next part of the problem, thereafter the elevator will be moving with uniform velocity while the body will have acceleration. Acceleration of g, initial velocity, everything will be taken with respect to SR equal to UR into T plus half AR into T square. Is the problem clear to all?
Yes, sir. Yes, sir.
In this case, they are conveniently given you a situation where the body will meet before the elevator stops accelerating. Suppose if the body meets after the elevator stops accelerating, then I'll have to deal with the problem in two phases. First phase, elevator is accelerating continuously and it acquires a speed of what we call as 7.8 meters per second. Thereafter, it is moving with uniform velocity, and this body strikes and comes here. Somewhere from here, it goes and comes and falls here. Right?
Yes.
Now I'll have to split the problem into two parts if it so happens. But here that doesn't happen. The numbers are conveniently adjusted. How much are you getting the answer from this tree? 3.67. According to the answer given, you should get 3.67. Because the answer given is 5.67. 3.67 plus this 2 seconds, you should get the answer.
So near about 3.5.
Yeah. Plus 2, you will have 5.5. Right? Because
Yes,
2 seconds. You are telling me that 3.5 from here.
Yes, sir.
So plus the 2 seconds initially also should be added. That will be your final answer.
Yes, sir.
Fine. Listen to this. We take the concept of relative velocity one step ahead. Till now in the concept of relative velocity that we were dealing with, it is only linear, either vertical or linear. Maximum they can make that the simplification becomes lengthy. They keep increasing the number of steps of the problem. They will tell you first part it was accelerating, next part is moving with uniform velocity, next part it is accelerating or decelerating, so on and so forth. This is the maximum that they can do when it is linear motion. That too in one dimension. What if two people are moving in this particular direction? Now for you to visualize will be difficult. Say one person is here, one person is here. This is the target. This person moves in this direction, this person moves in this direction. I am standing here and a student is standing here. Now both of us are running towards the door here. You are running from there towards the door. I am running from here towards the door. It so happens that you are running faster and we both meet at this particular point. So everybody seeing us in the classroom will tell the world that these both people ran towards the door and they met at the door. But
Yes,
then,
sir.
if there was an ant on my shirt, and the ant describes the motion of the student, how will it describe the motion of the student?
Towards you.
You're right.
Sir.
The ant will feel that the student went straight towards me. Why? The concept of relative velocity is all about describing the motion of the second body with respect to the first body, or describing the motion of the first body with respect to the second body. Now, I am asking you to describe your motion with respect to me. That means I should be at rest. The ant doesn't recognize the fact that I am moving. It will feel I am at rest. So if I am at rest, there is only one way in which the ant will only see that you are meeting me. How will the ant feel that you are meeting me if I am at rest? You should be moving straight towards me. With what velocity should you move? Should you be moving towards me? You should be moving with uniform velocity. And that will be the relative velocity. In simple language, when I am here, you will be somewhere here. That means the ant will see the distance between us decreasing. When I am here, you are somewhere here. The ant sees the distance further decreasing. When I am here, the ant is here. I mean, you are here. And at this particular point we meet. Implies the ant doesn't recognize the fact that I am moving. Instead, it recognizes the fact that you are moving straight towards me. In simple language,
Yes,
as far as I am concerned, the sun is going around the earth. The statement is 100% right. When I describe the motion of the sun with respect to the earth, or say I am sitting inside a train which is going ahead and the other train is at rest. So actually everybody on the ground feels that the other train is at rest and my train is going ahead. But I will feel that the other train is going back. So if I tell you that the other train is
Yes,
going
sir.
back, my statement is right, provided I tell you that I am describing the motion with respect to me.
Yes, sir.
Yes, sir.
Hence, you should tell us with respect to what you are describing the motion. With respect to the earth, sun is going around the earth, statement is 100% right. There's nothing wrong in it. Same is the situation here. Everybody on the ground will see the student moving by this distance and I moving by this distance. But the ant on my shirt will not recognize the fact that I am moving. It will feel the student is coming straight towards me with what velocity? With relative velocity. Relative velocity of the student with respect to me. Vice versa is equally true. If the ant was on your shirt, it will not recognize the fact that you are moving. The ant will feel that I am moving straight towards you with what velocity? Relative velocity of mine with respect to you. Let
Yes,
us
sir.
put this proof in mathematical terms. In mathematical terms, how do you put this proof? This is the position vector of first particle and this is the position vector of the second particle. Now if they are supposed to move, this should move in this direction, this should move in this direction. Both start moving simultaneously. Both start moving simultaneously. If by chance this is moving in this direction and this is moving in this direction, they will never meet. This is V1t and this is V2t. This is V1t and this is V2t.
Yes,
Right.
sir.
Why are you taking V1t here? Why not V1? Because R1 and V1 cannot be added. Distance cannot be added to velocity. Hence you are taking V1t. That means in time t, if this travels a distance, in the same time this should travel this distance. Only then they will meet. That means if the two particles are meeting here, for me the condition R1 plus V1t, R1 and V1 are two sides of a triangle taken in one order. The third side of a triangle taken in the reverse order should be equal to R2 plus V2t. Do you all agree with that?
Yes.
R1 plus V1t should be equal to R2 plus V2t. Now when these both, sum of these two is equal to sum of these two, then the resultant diagonal for both of them is the same. And hence I can say that the two particles are meeting. Now you may ask, how reasonable is this? You are supposed to find out if the two particles will meet or not. Instead you are already assuming in the first step that the two particles are meeting. In fact, I will first impose the condition that the two particles will meet and I will make sure that the time should be a positive proper number. By chance, if I take the condition that the two particles are meeting and I calculate the time, I get a negative value for it. That means the two particles are not meeting. If I get
Yes,
a
sir.
positive value for it, that means the two particles will meet somewhere. Yes or no?
Yes, sir.
So now I forcibly impose the condition that the time should be positive. How do I do that? R2 minus R1 will be equal to V1 minus V2 into T. So T will be equal to